This is lesson 2 of systems of linear equations and linear inequalities. So again, we're still in the review part of solving non-linear systems. So the graph of a linear equation is always a straight line. So it's always a straight line, and then the equation which represents a graph that is not a straight line is called a nonlinear equation. So we call them as nonlinear equation. So nonlinear systems of equation. So if we have system of equations and is nonlinear. So in lesson 1, we're talking about a linear system of equations. Well, a nonlinear system of equations is a system in which at least one equation does not represent a straight line. So one of the graph will not give you a straight line. So let's try to consider this particular example here. So consider the system of equations. So you have a linear equation that is given by x plus 6. Okay. And then the other one is given by y is equal to x squared. So if we can, in our previous unit, this is an equation of a quadratic function. So we know that a quadratic function is nonlinear because its graph is a parabola. So how do we solve the system using a graphing calculator? So if I go to my Desmos calculator, so you can see here, again, the red one gives me the nonlinear equation. So if you can see, it's a parabola. And then the second equation of the line gives me just a straight line. So how do we get the solution? So just like in the system of linear equations, the solution is given by the point of intersection between the two graphs. So in this case, we just have to look at the intersection, the point of intersection or intersections between the two graphs. So the red graph, which is given by the quadratic function, so a parabola, and then the linear one, which is given by the blue line here. So you have here 2 points of intersection, -2 and 4, and 3 and 9. So therefore, you have 2 solutions here. So we can write the solution as, you have 2 solutions. So the solutions are -2 and 4. So -2 and 4. And the other one is +3 and 9. So 3, +3 and 9. So if we're gonna sketch the graph, we can copy the graph that we get here. It's a quadratic function. It's just a parabola. So the vertex is at 0, 0. And then we have the straight line. So that would be, so it hits the graph twice. Okay. So the point of intersections are this. So this would be your solutions. So you have 3 and 9. And negative 2 and 4. 2 and 4. So these are your solutions. So to verify our solutions, so all we need to do is just substitute this one to our function. So remember that that would be the value of x. So always this is x, and then you have the value of y. So this is the value of x, the value of y. So looking at again the solution. So for the first one, the first solution, x is negative 2 and y is 4. So I'm just gonna substitute that value. So this value here with 4. So y is 4, and that is equal to, and x has the value of negative 2. So negative 2 squared. So if you can see, you have 4 is equal to 4. So that means that indeed negative 2 and 4 is a solution to this quadratic equation. The y is equal to x squared. So how about 3 and 9? So again, you just have to substitute the value of x and y. So y has the value of 9, and then that is equivalent to the value of x, which is 3, and then squared. So if you can see, that's 9 is equal to 9. So again, 3 and 9 is a solution to y is equals to x squared, so the quadratic equation. So we also need to check whether these points, negative 2 and 4 and 3 and 9, is a solution to your linear equation. So the linear equation is given by x plus 6, y is equals to x plus 6. So again, I'm going to use the first point, negative 2 and 4. So I'm going to substitute the value of y, which is 4, and that is equal to the value of x. The value of x is negative 2, and then plus 6. So if you can see, this is 4, and that is equivalent to 4. So both are equal, so therefore you would say that negative 2 and 4 is a solution to your linear equation y is equal to x plus 6. So we have the other solution, which is 9. So y is 9, and then equal to, what's the value of x? The value of x is 3. So I'm going to replace that one with 3, and then plus 6. So that would give you 9 is equal to 9. So therefore, 3 and 9 is also a solution. So the point with the coordinates of 3 and 9 is also a solution. So remember, that's how you verify your solutions. So you just have to substitute the values of x and y in your equation, and if both sides of the equation gives you the same value, then indeed that would be a solution. So let's move on to example number 2. So consider the following system of equations. So y is equal to 2x squared minus 5x minus 17, and then, so if you can see here, both are quadratic functions. So these are just quadratic functions. So quadratic. Again, that is quadratic because the highest degree term will have a degree of 2. So this system has two solutions. State the appropriate graphing window and sketch the graphs of it. equation. So we will not do that because anyway we'll just be using Desmos. So what I'm gonna do is I'm gonna uh, place these two quadratic equations in my Desmos calculator. So first one is I'm gonna uh, x squared, and then it's 2x, 2x, and then negative 5x minus 5x, what's that? Minus 5x minus 17. Okay, so this is your quadratic function, the first quadratic function. The second one has an equation of negative 2x squared, so negative 2x squared, and then plus 3x plus 15, plus 3x plus 15. Okay, so again, the solution would be the point of intersection. So I will be looking at the point of intersections, not the x-intercepts of the two graphs, but the point of intersection. So this is one of the point of intersections, negative 2 and 1, and the other one is 4 and negative 5. So therefore, those are the solutions. So if I'm gonna go back again, it's just a graph. One is upward, and the other one is opening downward. So like that. So the sketch would be something like this, and then so it's just something like, oops. Okay, so it should be a parabola. So maybe you can draw better than me. So that's a parabola there. So it has two point of intersection. So the other one has an intersection at the bottom. So it should be something like, so just copy that one. Oops. So it should be something like that. Okay, so this should be a parabola. So it's a very bad drawing. However, yeah, you can make it better, but it has two solutions. So the solutions of the system would be again, that's negative 2 and 1. So negative 2 and 1, and the other one is 4 and negative 5. 4 and negative 5, and 4 and negative 5. So these are the solutions. Again, you can verify that one by substituting these values into your equations. So again, or you can write this one as, or x is equal to 4 and y is equal to negative 5. X is equal to 4 and y is equal to negative 5. And as well as the other solution, you can write it as x is equal to negative 2 and y is equal to 1. So both of these are solutions to your equation. So again, if you're going to replace this into the equation, it will give you the left hand side of your equation, the right hand side would be equivalent. Okay, so let's take this example number 3. Consider the following quadratic equation. Explain how a system of equations can be used to determine the solution of this can be used to determine the solution of this quadratic equation. So how could you use a system of linear equation? Well, what you can do is you can break it down into two equations. So this is just your first equation, a quadratic equation. So you can assign this one as your first equation. So I will call this one as y1. Okay. So y1 is equal to that. So therefore, this equation here can be written as y1 is equal to 2x squared minus 13x plus 15. And I'm gonna make the other side here as my y2. So this would represent a linear equation. So y2 is equal to 0. So with that, we can actually get the solution of this particular quadratic equation. So we break it down into a quadratic equation and a linear equation. So the left hand side as your quadratic. So if you can see, this is just the left hand side of the equation. So I'm gonna graph that one. If I'm gonna graph that, it gives me a quadratic graph, which is a parabola. And then the other one, y is just equal to a constant, will give me a linear graph. So graphically determine the solution of this equation. So we go to our Desmos calculator. So again, we just have y is equal to 0 as our first. So if you can see, I'm just gonna use I just gonna use a different color. So let's see. So to emphasize, so that would be orange. So if you can see, it's just a straight line that hits your x-axis. And then the other one would be 2x squared. So you're going to write 2x squared and then minus 13x. So minus 13x and then plus 15. Okay. So if you can see, the point of intersection between this orange line, straight line, and the red line would be the solution. So you have two solutions here. And it's the same thing as solving quadratic equation. You're going to set it to 0. So essentially, you're just finding the x-intercept of your quadratic function. So that would be the solution of your quadratic equation. So if you can see, that's 1.5 and 5. So the solutions of this would be 1.5. So x is equal to 1.5. 1.5. It's not 1.0 but 1.5. And x is equal to, so again the other x-intercept, that would be 5.5. No, 5.0 or 5. So these are the solutions of that quadratic equation. Okay, so you have two solutions. So it's just the same thing as, well, if you're going to use the system of equations, you're just going to break it down, the left hand side and the right hand side of your equation, into two different graphs. So that gives you that value. So the value of x would be equal to 1.5, and then x is equal to 5. So that's how you get the solution. So again, if you're gonna verify this one, if you're gonna verify your solution, so what you're gonna do is just replace. So 2 times 1.5 squared minus 13 times 1.5, and then plus 15 should be equivalent to 0. So if you have this type of equation that involves an exponent, so just try to remember to do that first before you multiply it by 2. So 1.5 squared, then multiply it by 2, that gives you 4.5. So that's 4.5 minus 13 times 1.5, that gives you 19.5. 19.5 and plus 15. So this is 4.5. So this gives you negative 15 plus 15. That's 0. So 0 is equal to 0. So therefore 1.5 is a solution. You can also use x equals to 5. So let's see. So 2 times 5 squared minus 13 times 5 plus 15 is equal to 0. So this would be 25 times 2, that is 50, minus 13 times 5, that's 65, plus 15 is equal to 0. 65, negative 65, or 50 minus 65 is negative 15 plus 15 is equal to 0. So 0 is equal to 0. So therefore, 5 is a solution. So again, that's how you verify your solution. So let's